Hello everyone. So in our previous video we discussed that how we can calculate the time complexity of a linear algorithm. So in this video we'll discuss that how we can calculate the time complexity of a polynomial algorithm. So here we are given an algorithm and we are also given an integer n. Now what we are doing in this method is we have provided a for loop which goes from I equal to 1 to less than equal to n, and it gets incremented by 1 for each iteration of this for loop. And for each iteration of the outer for loop, we have again provided a for loop which starts from j equal to 1 and goes till j is less than equal to n, and it also gets incremented by j plus plus. And inside this inner for loop, we are simply printing the value of I and j on the console. And after this inner for loop gets executed, we are printing end of inner loop, and after this outer for loop gets executed completely, we are printing end of outer loop. So here you can see if we run this code, let's say for value n equal to 3. So here you can see that this gets printed on the console. So in our previous video we also discussed that this outer for loop will go from I equal to 1 to I less than equal to n, which is 3. So it will get executed 3 times, the outer for loop, and for its each execution the inner for loop will also get executed exactly 3 times, because j is also starting from 1 and j is also going till j is less than equal to 3. So here you can see that what it gets printed on the console. So for I equal to 1, inner for loop gets executed n times. So here you can see I equal to 1, I equal to 1 and I equal to 1. So for I equal to 1, the inner for loop will get executed n times, where j will go from 1 to 3. So here you can see j equal to 1, j equal to 2 and j equal to 3. And after inner for loop gets executed, end of inner loop gets printed, which is here. And once it gets finished, the execution point reaches here, does increment of I by 1. So I becomes 2, and we know that 2 is less than 3. So therefore again the inner for loop will execute from j equal to 1 to j is less than equal to n, and this will get printed 3 times because the inner for loop will get executed n times. So for I equal to 2, the inner for loop gets executed from j equal to 1 to 3. Then we print end of inner loop here, and then again I gets incremented to 3, and for I equal to 3, the inner for loop will again get executed 3 times. And then here we print end of inner loop, and then we again increment I by 1, so I becomes 4, and 4 is not less than equal to n. So therefore the condition breaks, and finally we print end of outer loop. So here you can see that for each iteration of outer for loop, inner for loop gets executed that many number of times from j equal to 1 to j is less than equal to n. So here in this example, as we have taken value of n as 3, so you can simply think that outer for loop gets executed 3 times and inner for loop will get executed 3 into 3 times, which is 9. So here you can see that this statement gets printed 9 times. For each value of I, inner for loop gets executed from 1, 2, 3. For I equal to 2, it gets executed 1, 2, 3. For I equal to 3, it gets executed 1, 2, 3. So usually this statement at line number 4 gets executed n square times. So let's see how many operations are getting performed on each line. So for line number 2, so in our previous video we already discussed that how many times this for loop will execute. So this assignment integer I equal to 1 will get executed exactly 1 time. We are accessing I, we are accessing n, and then we are comparing. So this will get executed exactly n plus 1 times, because so when we are providing value of n as 3, so when I becomes 4, this condition will comes out to be false. So therefore we provided value n, and this will get executed exactly n plus 1 times. This is the same stuff which we discussed in our previous video. And then this I plus plus will also get executed 3n times. So this for loop will execute n times, so it will take 3n times. And if we do the sum of it, it will take 6n plus 4 unit times. Now let's see about the operation taken by the inner for loop. So here you can see the condition are exactly same. So here we know that it will take 6n plus 4 unit time, the inner for loop, because j is also getting started from 1 and it will also go till j is less than equal to n, and we are simply doing j plus plus. So here line number 4 will get executed 6n plus 4 unit of time, but this for loop will also get executed multiple times based on the execution of outer for loop. So if outer for loop runs n times, the inner for loop will run n times of the outer for loop, so which will give us 6n square plus 4n unit time of execution. Moving ahead, at line number 4 we are accessing I, we are accessing j, and we are printing. So there are total 3 operations. And how many times it will get executed? You can see for value of n equals to 3, it got executed 3 square times, which is 9. So here the total operations would be n square times 3, which will give us 3n square. The line number 6, which is the end of inner loop, will get exactly printed n times. So here if n was 3, it printed 3 times, and for n times it will get printed n into 1 times, which takes n unit of time. And the line number 8 will get executed exactly 1 time. So if we add all the unit times, we get the total time would be 6n plus 4 plus 6n square plus 4n plus 3n square plus n plus 1. And if we add the n square terms and n terms and then the constant, it will become 9n square plus 11n plus 5. So here, as we assume that we take value of n to be very large, we ignore the lower order terms, and we also ignore the constant multipliers, so we remove 9 also. So if you want to represent the time complexity of this algorithm, it would be O of n square, because rate of increase of time is getting directly proportional to n square. And if we plot the graph with time versus the input size, it will give us a parabolic curve where execution time will increase by n square. So here you can see that as volume of data will increase, the execution time will increase n square times, because time is directly proportional to n square. So this is the graph for a polynomial algorithm. So here you can see that this is a really bad algorithm because execution time is drastically increasing with the input size. So usually we try to avoid the nested for loops, because for each outer for loop, inner for loop gets executed that many number of times. So which you can see by the operation at line number 3. So here you can see, based on the condition provided here, inner for loop gets executed n times the outer for loop. And also friends, similarly, let's say if we had one more for loop inside the second for loop, this would have gone to n cube times, based on if the condition here provided are same. So it would have taken O of n cube time, so which is also a polynomial algorithm and which is also really bad. So here in this video we discussed about that how we can calculate the time complexity of a polynomial algorithm. I hope you like this video. Thanks, have a nice day.